Okay, now let's try some mixed stoichiometry. So remember, when you're going from one substance to another, you always need to use your mole ratio. It comes from your balanced equation. The beginning and ending conversions are going to change now based on what you have been given and what you are asked to find. Always going to use a mole ratio though. Some reminders. Grams or mass means you have to find the molecular mass of the compound involved. Volume, use your 22.4 liters. Moles, go straight into your mole ratio if they give you moles. There's no need to turn your moles into grams just to turn it back into moles. So if they give you moles, go straight into your mole ratio. If you're asked for moles, you're going to stop at the mole ratio. Remember, molecular mass is 1 mole, 22.4 liters is going to be opposite 1 mole, and Avogadro's number 6.02 times 10 to the 23rd is going to be opposite 1 mole. The unit and the substance that you want is going to go in the numerator. The unit and the substance that you already have is going to go in the denominator. You've got to use dimensional analysis. You've got to include your unit and your substance so that when you get to the end, you know what you're looking for and your setup is going to appear correct. So, how many liters of water can be produced from 4.18 grams of hydrogen? Identifier starting. We're starting with 4.18 grams of hydrogen. That means we're going to use the hydrogen in the reaction. We are looking for liters of water. So we're going to use the water in the balanced reaction. So write down what you're starting with. We're starting with 4.18 grams of hydrogen. Grams always has to be turned into moles. So 1 mole is going to go on top. Since we have grams, 1 mole is going to be opposite molecular mass. H2 weighs 2 grams. Do we want moles of hydrogen? No, we want water. So we have to use our mole ratio from our balanced equation. So mole of water is going to go in the numerator. Mole hydrogen in the denominator. The coefficient for water is 2. Coefficient for hydrogen is 2. Do we want moles of water? No, we want liters of water. So now in this conversion factor, we're going to have our 22.4 liters of water in the numerator because we're looking for liters of water. 22.4 is always opposite 1 mole. We got to get rid of that 1 mole of water unit. So now your math, if it's in the numerator, you multiply. If it's in the denominator, you divide. So 4.18 divided by 2 times 2 over 2, that's just 1, so we can skip that, times 22.4 gives us, how many sig figs can you have? 1, 2, 3. So we're going to report our answer as 46.8 liters of water. Let's try another one. How many grams of sodium chloride can be made from 18.9 moles of hydrochloric acid? So we're going to be starting with 18.9 moles of HCl. There's our hydrochloric acid. We are looking for grams of sodium chloride. So we're going to look at the sodium chloride. This equation, our reaction, is not balanced. So let's go double check. There's no coefficients, but it is balanced. So 2 hydrogen, 1 chlorine, 1 chlorine, 1 sodium, 1 sodium, 1 oxygen, 1 oxygen. So it is balanced. There's just no coefficients because it's balanced. So write down what we're starting with. We are starting with 18.9 mole of HCl. Since we're starting with moles, do we need to turn it into anything else? No, we can go directly into our mole ratio. So what we're looking for is sodium chloride. So mole NaCl is going to go in the numerator, trying to get rid of that mole of HCl. So go to your balanced equation. It is 1 to 1. Do we want moles of sodium chloride? No, we want grams. So molecular mass of sodium chloride, 23 plus 35 is 58. Molecular mass is always opposite 1 mole. So 18.9 times 1 over 1 is just 1 times 58. How many sig figs can we have here? 1, 2, 3. So we're going to report our answer. Originally we get 1096.2. But to get 3 sig figs, 1, 2, 3, that means we're going to have to round this up to 1100. Well, that's still not 3 sig figs, so we're going to have to use scientific notation. So we're going to report it as 1.10 times 10 to the 1, 2, 3. And our unit is grams NaCl.